So this morning we're going to look at converting between decimals and fractions. Now we've been doing a lot of work on decimal place value, and today we're only going to go up to 3 decimal places, okay? So this column is going to be 1 decimal place, 1 DP, 2 DPs and 3 DPs. Okay, DP stands for decimal place, obviously. So there we've got 4 numbers that have got 1 decimal place, so 0.3, 0.6, 0.9 and 0.8. So let's have a look at some 2 decimal place ones. There we go, 0.25, 0.65, 0.88 and 0.37. 3 decimal places. And there's some 3 decimal places, 0.285, 0.335, 0.628 and 0.999. Now, when we are converting from decimals to fractions, the thing that you have to look at is the place value. You have to look at how many decimal places there are, okay? And if there's 1 decimal place, you make it a fraction over 10, okay? If there's 2 decimal places, you make it a fraction over 100, that's right. And 3 decimal places, you make it a fraction over 1,000, that's right. Because obviously, this is tenths, hundredths, thousands. That's 285 thousandths, isn't it? 335 thousandths. So, you take the number, the digit that is in the decimal place and put it over the fraction. So here we've got 3 tenths, here we've got 6 tenths, here we've got 9 tenths, and here we've got 8 tenths. Now some of them are fine, we can leave them, but what do we always do with fractions? Simplify them, that's right, okay. So, 3 over 10. Is that in its lowest terms or its simplest form? It is, isn't it? We can't change it, so it stays as 3 over 10. 6 over 10, is that in its simplest form? So what is it, Eden?
3/5.
Well done. 3 over 5, because they both divide by 2. 9 over 10, is that in its simplest form? Yes, so we can leave that. 8 over 10, is that in its simplest form?
4 over 5.
4 over 5, that's right, okay. So that's how you change a number with 1 decimal place into a fraction. Very straightforward. Obviously, if it's an even number, so 2, 4, 6 and 8, you will have to simplify. If it's an odd number, like 1, 0.1, 0.3, 0.5, 0.5 you'd have to simplify, wouldn't you? Because that would simplify to what? A half, well done. Then 0.7 and 0.9. Okay, so let's look at what it says you have to do. Put the numbers, the digits in the 2 decimal places over 100. So 25 over 100, 65 over 100, 88 over 100, and 37 over 100. And again, what we need to do then is decide whether or not they need simplifying. So, 25 over 100, what is, be careful here, what is the highest common factor? Colleen?
5.
Right, it is a common factor, but it's not the highest one. What number goes into 25 and 100?
4.
No, you're kind of on the right track because you're thinking it through, but it's not a common factor. 4 doesn't go into 25.
25.
25 is the highest common factor, isn't it? That's right. So how many 25s are there in 25? There's 1. And this is where you were thinking, Megan. How many 25s in 100? There are 4. That's right. So 0.25 in lowest terms is a quarter. Now 0.65, 65 over 100, highest common factor of 65 and 100. What's the highest common factor? Cody? It is 5 in this case, yeah, because 65 doesn't divide by 15. Neither does 100. And they don't divide by 25, so it's only 5. So how many 5s are there in 65, Ethan? 13. And this is something that you need to know. You need to learn this. How many 5s in 100? 20, that's right. You need to just know that off by heart, really. Okay, 0.88, 88 over 100. Highest common factor. If you don't know the highest common factor, because they're both even, what can you do? Halve them, that's right. So we've got 44 over 50. And we can halve those again, can't we, to what? 22 over 25, that's right. And that's lowest terms. Okay, the last one, 37 over 100, highest common factor. Bit of a trick, this one, really. What is 37? What type of number is it? Prime, that's right. So they've got no common factors. So it's actually 37 over 100 stays as it is because you can't simplify it any further. Okay? So 3 decimal places. Same process. Here you put 1 digit over the 10. Here you put the 2 digits over 100. Here you put the 3 digits over 1,000. So 285 over 1,000, 335 over 1,000, 628 over 1,000, and 999 over 1,000. And if you come from the UK, the number 999 has a special significance, doesn't it, Ethan?
Yeah.
What is it?
Emergency.
Yeah, it's phoning the police, that's right. Here it's 000, in England it's 999. Okay, so 285 over 1,000. What is the highest common factor? They both divide by something. 5. They both divide by 5. So this is quite tricky though. If there are 25s in 100, so there's 25s in 100, 25s in 200, how many 5s in 85? 17, well done. So how many 5s in 285?
57.
57, well done. Okay, now if there are, listen to the pattern, 2 5s in 10, 25s in 100, 200 in 1,000, that's right. So 57 over 200. And again, there are no more common factors. 57 does divide by 19, but 200 doesn't divide by 19. If it was 57 over 190, it would have simplified. Okay, 335 over 1,000. Well, we know what the denominator is going to be, don't we, first of all? It's going to be 200, because it's the same. 335, how many? So here again, we've got another 100, 20 more, and then 35. How many 5s in 35? 7. So 67, that's right, 67 over 200. Okay, 628 over 1,000. Now, I wouldn't know what the highest common factor of those are. I wouldn't know. It might be 4, it might be 8, I don't know. But what would you do if you were given 2 numbers like this that were both even? Where would you start? You'd halve them, that's right. So can you halve them for me, Marcus? 314 over 500. Okay, both still even. So what can I do?
Half them again.
Yeah, so it'll be
157 and 250.
yeah, over 250, and no common factors for those. Okay, and then 999 or 999 over 1,000. Any common factors? No, so it stays as it is. It stays as 999 over 1,000. Okay, so the three things you have to remember: if it's one decimal place, you put it over 10. Two decimal places, you put it over
100.
3 decimal places, you put it over
1,000.
and then when you've done that, you have to look to see if you need to simplify. That's right. Only you could do it with the wand. Simplify. It'd be really good, wouldn't it? Right, okay. So what we're going to do now then is we're going to look at converting fractions into decimals. And this is where you might need your calculator out if you have one. Yes. For some of it and some of it not. Some of it you need to be able to do mentally and then some you don't, okay? And I'll show you which one. So, let's have a look. Okay, so we'll start with those fractions. 1/2, 2/5, 4/5, 7/10, and 8/9. Now, most of them are on that list of ones that I gave you that you need to know off by heart. So these ones you should really be able to know them off by heart. But what I'm going to show you is how to do it if you don't have your calculator with you and you don't know it off by heart. So, to change a fraction into a decimal, what we do is we divide, okay, we divide the numerator by the denominator, that's right. So let's have a look at 1/2, how we do that. So, we divide the numerator by the denominator, okay? So, it's 1 divided by 2. Think. No, listen. Right. Now, this one, you are going to have to add some extra digits to help you do it. So I'm going to put a decimal point there, and I'm also going to put a decimal point there, because obviously the decimal points have to relate to each other. So, how many 2's are there in 1? There's none. You can't divide 2 into 1. So you put a 0. And then you carry the 1 across and add another little 0. Okay? Now, how many 2's in 10? 5, that's right. And lo and behold, 1/2 is 0.5, isn't it? But this is showing you why it works. Okay, 2/5. So we do 5 into 2. Now again, we know it's going to be too big, so we put our little decimal point, put your decimal point here. How many 5's are there in 2? None. That's right. Okay? And then we carry the 2 across to there. How many 5's in 20? 4. And 2/5 is 0.5. It's like magic, isn't it? Okay, 4/5. 5 into 4. Again, how many 5's in 4? None, that's right. So we put the 0 with the decimal point, put the decimal point, and add another 0, and carry the 4 across. How many 5's in 40? 8. 0.5, that's right.
0.8.
Yeah, 0.8.
0.5.
Oh, sorry, 0.8. Okay, this one then, we've got 10 into 7. How many 10's are there in 7? None. So we put a 0 and we carry the 7 across. How many 10's in 70? 7. There you go, and that shows you why it works. Now this one, a little bit more tricky. We might have to keep going, and it might be a few more decimal places, and it might actually then we might have to round it, which is what we learned before. So it's going to be 9 into 8. Now, how many 9s are there in 8? None. So we put the 0 and the thing there, and we carry the 8 across. How many 9s in 80? And what is the remainder?
8. 6 remainder of 8.
6 remainder of 8.
Oh, 7. 6 remainder of
9 9s are 81, remember?
7.
9 9s are 81.
8.8.
8 remainder 8, that's right. So it's 8 remainder 8. Oh, what might happen here? 9 into 80. Well, we've just done that. It's 8 remainder 8.
Oh, it's just
9.80. 9 into 80. It's 8 remainder 8. So what do we do when we get a number like that? Jimmy? Yeah, well done. You can either put a dot on the top, or you can do it to 2 decimal places and write the little line across the top. So what does that little line mean, Marcus? Recurring. Well done. So basically what that means is we could carry on doing this forever and ever and ever and ever and ever. If you were bored and you wanted to, and it would always be 8 remainder 8, 8 remainder 8, 8 remainder 8. It wouldn't change. Now, what I want you to do though is do it on your calculator. I want you to do 8 divided by 9 on your calculator and tell me what happens. 9. That's right. The last digit is a 9. Not because it would be a 9, but what does the calculator do to the last digit, do you think? It rounds it, yeah. So 8 is nearer to the next one, so it rounds it to 9. So don't think that a number isn't recurring just because the last digit on your calculator is different. Your calculator has actually rounded it. Okay. So what happens then if you've got something quite complicated like 12 over 17? So this one is going to be 17 into 12. It's going to be trickier. So it's going to be 0 point something. So how many, and so we have to move the 12 across to 120. So now, how many 17s are there in 120? So we've got 17, 34, 51, 68, 83. Is that right?
100?
No, it can't be. 17 doesn't divide into 100. 34, 51, 17. Oh, I've only added 15. It should be 85. Yeah, because I thought, and then it's 102 and 119. So how many? 7. So 1, 2, 3, 4, 5, 6, 7. 7 remainder what? 1. How many 17s in 10? None. So we have to do that. Then we move it across. How many 17s in 100?
5.
Yeah, 5 remainder 15. That's right. So what you would do, you would probably just stop there, okay, and then round that up. So it would round to 0.71.
Is that a question how to do on the test?
No, you wouldn't get one like that on the test. Something like that you would use your calculator for, but I wanted to show you that it can be done without a calculator. Okay? Right, do you want to stop for me? Thank you.